Determine where a function is discontinuous. Given a function defined by this, f of x is equal to x squared plus 2x minus 3 all over x plus 3, where is the function discontinuous? So where? Again, you have to go back to our criteria for telling if a function is continuous or not at a certain point. So when one of this is not met, then you would say that the function is not continuous at that value of x. Now this is a rational function. Right away you know that when x is equal to -3, f of -3 does not exist. It is undefined. And so you would say that f of -3 does not exist. And so when x is equal to -3, your function is discontinuous or not continuous. Not continuous when x is equal to -3. Now let us not stop there, okay? Let us not stop there. Let us investigate the limit of this function as x approaches -3. What is the limit of our function as x approaches -3? Question mark. Well, this is the graph of our rational function. Well, maybe at the first glance, you are expecting something that has a vertical asymptote or horizontal asymptote. But this one, x squared plus 2x minus 3 divided by x plus 3. This one has a common factor because you can write the numerator, the polynomial in the numerator as x minus 1 times x plus 3 divided by x plus 3. And so x plus 3 divided by x plus 3 is 1. And so you are left here with x with the function that is equal to x minus 1. But x here must not be equal to -3. Okay, so it turns out that the graph of this function is a line. Okay, look at that. We have this open circle. So that means your function has no value when x is equal to -3. Okay, so what is the limit of our function as x or when x approaches -3? So we can approach -3 from two directions. We can approach -3 from the left, in which case our function approaches that point, and the value of our function at that point is -4. Look at that. We can also approach -3 from the right, and our function approaches this same point. And so the limit as x approaches -3 from the right is also -4. So what do we have here? Okay, so we have a function that is not continuous when x is equal to -3. Why so? Because f of -3 does not exist. But its limit exists when x is equal to -3. And the limit of our function as x approaches -3 is equal to -4. And so what is this telling you? Well, what this is telling us is a function can be discontinuous at a point when any one of the conditions for continuity at a point is not met. But it can happen. It can happen that f of -3 does not exist, or f at a does not exist. It can happen. F of a does not exist, but the limit of your function when x approaches a exists. So something like that can happen.